are this way shaded to the right. Open interval. Now, where they intersect, that's the tricky part. So, where set D intersects with sets E, where do they overlap? Well, let's find out. D's graph and E's graph, if they were placed on the same graph, let's see. So here's 0, here's 1, here's 2. Here's D's graph. That's the solution set of D's graph. This is the solution set of E's graph. Where they intersect is nowhere. They don't overlap at all. So this is the graph of the intersection, but the solution then to it is there is no intersection. So the answer is nowhere. And that means the final answer is an empty graph because they don't intersect anywhere. So this is the answer. So it's just going to be a blank line. This is just to help you. So I'm going to write, this is where D intersects with E. That's this line. Unfortunately, this is just to help you place them. And therefore, there is no solution. And they don't overlap anywhere. So this is just a guide. But this is the actual graph to that solution set. Okay? So that means there is no interval notation other than the empty set. And that's what that means. Okay. All right. So now on the back page, I'm going to show you an example solving each compound inequality and graph the solution set. So this has the word and in there, which means automatically you should know this is where the intersection is. So you want the intersection of both this graph and this graph. They're asking you, what is the solution to this compound inequality of this graph and of this graph? So you're going to treat these two like two separate inequalities and then combine them. So you're going to go ahead about your normal way and solve for x. So I'm going to subtract 2 from either side. So I have 5x is less than or equal to 15. I'm going to solve for x by dividing both sides by 5. So x is less than or equal to 3. So they want to know, okay, yeah, I have all my x values less than or equal to 3. And how does that overlap with this graph? Well, we have to solve for x here first to find out the solution set. So we have to add 6 to both sides. And we're going to go ahead and solve this the normal way. We're going to divide. But be careful. As soon as you see that we're dividing by negative, you should automatically think right away that, warning, warning, warning. When dividing or multiplying by a negative, this inequality sign flips and becomes a greater than or equal to a -2. So we want the solution set of this compound inequality where this graph and this solution, where they overlap, okay? Because of this word and means we want to find the intersection. If the word was or, then we'd want to write the union, where they unite. So again, and equals intersection, or equals where they unite. Okay. All right, so let's go ahead and graph this. All right, so I'm going to, here's 0, here's -2, here's 3. And so if I want all my x values greater than or equal to -2, that means -2 is included. That means everything over here is going to be shaded. I could keep going on and on, but I know I only want the overlapping part. And this is stopping me because this also says I want all my x values less than or equal to +3, which means 3 is my maximum and everything else is getting shaded before going lower, lower, lower. Notice I didn't keep shading though, because of this restriction tells me I only want the overlapping part. So that means everything greater than or equal to -2 up to and including 3. So that means x has to fall between -2 and +3. So this is the graph of my compound inequality of the intersection of that, because of the word and. So how I would write that in interval notation is exactly the symbols that we have here. It is closed interval. So the set of all, right here, I have -2 up until 3 included. They're both included. So this talks about all my x values between -2 and 3, including those two values as well. So that's the solution to that example. Now, I know you don't have anything else on your paper here until problem B, but I actually want to make an OR problem. So I'm going to ask you to copy down this OR problem here that I'm going to make. So x plus 3 is less than or equal to 5, or x minus 2 is greater than or equal to 3. So because of the word or, that means we want to find the union, where both graphs unite, or put them all together. Before we do that, we actually have to solve for each of these individual variables. So we're going to go ahead and solve that like we normally do. So to get x by itself, we're going to subtract 3. So x is less than or equal to 2. Or if we add 2 here, x is greater than or equal to 5. So we have two separate solutions. These graphs are going to look different. If we combine them on one, so here's the number 2, here's the number 5. All of my values that are less than or equal to -2, are from -infinity all the way up through and including +2. Here, I want all of my values of x that are greater than or equal to 5, which start at 5, including 5, and go all the way to infinity. So because this is an OR, I'm bringing both graphs together and uniting them on one. So we are good here, and this is actually how our graph looks for the union of these. And so in interval notation, against smallest number to greatest, well, we start out at -infinity, and we're going up to and including +2, but we also are uniting that with 5, including 5, so it's a closed interval at 5, all the way up to, but not including infinity. So we know that's going to be an open interval there. So that's how that solution works. So that's it for 1.5 day 1, and that's it for these notes. And good luck on your studying for your test. Thanks.